Two weights are suspended by three cables. Find the forces in cables AB, BC, and CD. Also find the angle theta CB. I have set up my engineering paper with the given and find information. The next thing I'm going to do is draw free body diagrams. I'm going to draw two of them, one for a particle at point B and one for a particle at point C. I've drawn my two free body diagrams. If we look at point B, there are three unknowns, the force in AB, the force in BC, and theta CB. If we look at the free body diagram for point C, there are also three unknowns, force BC, force CD, and theta CB. However, if we look at both of the free body diagrams and recognize that the force BC is repeated and so is theta CB, then our number of unknowns reduces to just 4. And if we write our equilibrium equations of summing forces in the x and y for both free body diagrams, we'll get 4 equations. So we should be able to solve for our 4 unknowns with our 4 equations. So let's do that next. I will write the equilibrium equations for our 2 points. I've written my 2 equilibrium equations for each of my 2 free body diagrams, for a total of 4 equations, and I number them 1 through 4. We've got 4 unknowns in our 4 equations, and at this point, thinking about solving them seems a little scary. But I'm going to show you a nice technique that would be a useful tool in your toolkit. I'm going to use this tool by first summing equations 1 and 3. Okay, here's the sum of equations 1 and 3. The first 2 terms from equation 1, the third and fourth term from equation 3, all equal to 0. Notice that the second term and the third term cancel each other out. That removes my unknown theta CB from the equation. And now I just have 2 unknowns in this one equation. And I'm going to solve for force CD in terms of force AB. Okay, I've now got force CD written in terms of force AB, and I'm going to call it equation 5. And now I'm going to continue by summing equation 2 and equation 4. You can see what's going to happen. My sign of theta CB is going to cancel out when I sum those 2 equations. Now the second term and the fourth term cancel each other out. And we're left with just 2 unknowns, force AB and force CD. So I'm going to substitute the value for force CD, which is equation 5, into equation 6. And this will allow me to solve for my unknown force AB. So I've replaced FCD with FAB cosine 55 over cosine of 75. And then I've grouped the negative 500 and the negative 300. So now I'll solve for FAB, and I get 270.3 newtons. If I plug in my answer for force AB into equation 5, I get that force CD is equal to 599 newtons. We've solved 2 of our unknowns, and we've got 2 more to go. The next thing I'm going to do is substitute my value for force AB into equation number 1. Another option is to substitute the value I got for force CD into equation number 3. Either of these substitutions will isolate force BC and the cosine of theta CB. I substituted the value for force AB of 270.3 newtons into equation 1. Then I isolated force BC. It's equal to 155.033 over the cosine of theta CB. I will call that equation 7, and I will substitute it and the value for force AB into equation number 2. When I substitute the value for force AB and the value for force BC in equation 7 into equation 2, I find we get this expression. 155.03 divided by the cosine of theta CB times sine of theta CB. Since sine over cosine is the tangent, I can rewrite this term as 155.03 times the tangent of theta CB. Now I can solve for theta CB. I get that it is 68.1 degrees. Now I have just one force left, force BC. I can use equation 7 to find it. When I substitute theta CB into equation 7, I find that force BC is 415.7 newtons. And we're done.